Hi, good morning, dear students. In the previous class, we learned about law of buoyancy and Archimedes principle. And now in this class, we are going to learn about relative density. Okay, so before going to relative density, first we'll know what is meant by density. So your density means it is a ratio of mass and volume. Okay, density means it is mass divided by volume. So that gives the density. And what is the comment me? What is the SI unit of force? Comment me. What is the SI unit of force first? So SI unit of force is Newton. SI unit of force is Newton. What is the SI unit of mass? Comment me the answer first. What is the SI unit of mass? And next one, what is the SI unit of distance? Then what is the SI unit of volume? Comment me the answer for these three questions. SI unit of force is Newton. Then what is the SI unit of mass and distance and volume? Okay, first one is mass, second one is distance, third one is volume. So all are commenting only for mass and distance. What is the SI unit of volume? So volume means it is having length, breadth and height. So the SI unit of mass is kg and SI unit of distance is meter and SI unit of volume is meter cube, because if you consider a square, it is having length and breadth. So therefore its area becomes a square if you consider the length as a, because it is having only length and breadth. If you consider a cube, then it is having length, breadth and height also. Length, breadth and height also. Therefore its volume becomes a cube if the side is a. So therefore here the length, breadth and height are measured in terms of meter. So that's why its volume becomes meter cube. But then when we come to the density, SI unit of density, first the SI unit of mass is kg and divided by SI unit of volume is meter cube. So therefore SI unit of density is kg per meter cube. Kg by meter cube, all small letters, or kg m raised to minus 3. Kg m raised to minus 3. So this is the SI unit of density. And this is the expression for density. Density equals to mass divided by volume. And SI unit of density is kg per meter cube. So this is about density. Now, this density does not vary from one thing to another. So therefore, for a particular material, the density remains same. Okay, almost same. Now here they give two examples of the density of gold. Density of gold is given, that is equals to 19,300 kg per meter cube, and density of water that is equals to 1000 kg per meter cube. So density of gold is given, that is 19,300 kg per meter cube, and density of water is 1000 kg per meter cube. Okay, here density of water is very important. That is 1000 kg per meter cube. It is constant, and we have to use that in problem. So the density of water. So the next one, example. So before going to that example, we'll write the expression for relative density, and we'll find out the expression or SI unit of relative density. Relative density. Relative density means density of one substance with the reference to density of other. Relative, one with the other. So here relative density is given as density of substance divided by density of water. So with respect to water it is given. So that is here relative density. So relative density of substance divided by density of water. Density of substance divided by density of water. So now, just I told you that the density of substance is a particular constant for a particular material, and the SI unit of density is kg per meter cube. Okay, SI unit of density is kg per meter cube. Now, comment me what is the SI unit of relative density, and expression relative density equals to density of substance divided by density of water. And now comment me what is the SI unit of relative density. This is very important concept. So relative density equals to density of substance divided by density of water, and we know that density of the substance is SI unit is kg per meter cube. Now comment me what is the relative density of the or SI unit of relative density. So if you know this, then you understood the concept. Because here relative density, I will derive this. Density of substance, its SI unit is kg per meter cube divided by density of water. Density of water, its SI unit is again kg per meter cube. So kg per meter cube gets cancelled. Nothing is remaining there. So therefore, relative density is unitless quantity. Okay. Because numerator also contain kg per meter cube and denominator also contain the SI unit as kg per meter cube. Both will get cancelled, only the value remains. Okay, therefore relative density is unitless quantity. Therefore relative density is unitless quantity. Relative density is unitless quantity. Okay, just remember this point. If you wrote relative density equals to 5 kg per meter cube, then your answer is wrong, because relative density is unitless quantity. Okay, based on this formula and this unit, will solve one problem, very simple one. So example 10.7. 10.7. relative density of silver is relative density of silver is 10.8. So see here, they give a relative density of silver is 10.8. They not give the SI in it because it is does not have any SI. Okay, it is a unitless quantity. The density of water is 10 raised to 3 kg per meter cube. 10 raised to 3 means 1000. Okay, in front of 1 we have to put 3 zeros. It becomes 1000. 1000 kg per meter cube. What is the density of silver in SI? What is the density of silver in SI unit? In SI unit. First we will write the given data. So relative density of silver is given. Relative density of silver, that is equals to 10.8. Then the next given is the density of water. Density of water, that is equals to 10 raised to 3. 10 raised to 3 means it is 1000, or directly you will write 10 raised to 3 kg per meter. Now we have to find out the density of silver. To find out density of silver, we have to consider the relative density formula. Okay, relative density equals to density of substance divided by density of water. Here the considered substance is silver, therefore it becomes density of silver divided by density of water. Okay, relative density equals to density of silver divided by density of water. Just substitute the values and comment me the answer. Gentlemen, just solve the problem and comment me the answer. No need to comment anything. So the relative density is in front of you and the density of water is in front of you. Just find out what is the relative density of silver. Even Tejashwini also, just solve the problem and comment. Okay, try to solve this problem fast. $10,800 kg per meter cube. Veerappa. Any other answers? Fast. Just rearrange the formula and then substitute. Otherwise, substitute the values and then rearrange the formula. Maltesh gave the answer as 10,800 kg. So while writing the answer, you must give importance to SI unit. We have related density so much 10.8. That is equals to density of silver. We don't know. I will write as it is. Density of silver divided by density of water is 10 raised to 3. Okay, when we cross multiply this, density of silver becomes density of silver equals to 10.8 into 10 raised to 3 kg per meter cube. Or when we multiply this, it becomes 10 raised to 3 becomes 1000. Okay, it becomes 10800 kg per meter cube. Okay, this is the solution. Because decimal point is present one digit before, so totally 3 digits before we have to put the decimal point. So therefore 1, 2, 3, 20 comes extra. Therefore density of silver is 10,800 kg per meter. How many of you understood this? Just comment your name and click on the like button. Fast. So relative density equals to density of substance divided by density of water, and the density of the substance is SI unit of density of substance is kg per meter cube, and the density of water is having the SI unit as kg per meter cube. Therefore, SI unit of relative density is unitless quantity. The next problem. Example 10.2. Example 10.2. So that is present in page number 136. A car falls off a ledge and drops to the ground on 0.5 second. Let g equals to 10 meter per second square for simplifying the calculation. Okay, the value of acceleration due to gravity or value of small g, that is 9.8 meter per second square. But for the easy calculation they gave 10 meter per second square. But if in exam they ask what is the value of acceleration due to gravity, or if they ask what is the value of small g, then you have to write 9.8 meter per second square. If you wrote 10 meter per second square, then your answer is wrong. Okay, now in this, a car falls from a ledge. That means a car falls from certain height. Therefore here initially the object is in rest position. So therefore initial velocity is 0 here. And drops to the ground in 0.5 second. Drops to the ground in 0.5 second. And the time taken is how much here? 0.5 second. That is half second. And here gravity is given. And gravity is 10 meter per second square. Now we have to find out what is the speed on striking the ground. That means we have to find out the final velocity. And second sub question is what is its average speed during the 0.5 second. So average speed means initial velocity plus final velocity divided by 2. That gives the average velocity. And third point, high is the ledge from the ground. That means we have to find out the height or distance of the object from the ground. First I will write the given data. Time equals to 0.5 second, or we can consider half second. Half second. Then the car falls from a ledge. That means initial velocity. Initial velocity, comma u equals to 0. Initial velocity, comma u equals to 0. Then they give the acceleration due to gravity. That means they give the value of small g. Acceleration due to gravity. Due to gravity, that is small g equals to 10 meter per second. Now we have value of a is not given. A means here g. And if the object is moving upward, then we have to consider negative. If the object is moving downward, then we have to consider positive, because the gravitation means it is an attractive force on the object because of Earth. That means it is the Earth attracts every object towards the center of the Earth. Therefore, in the downward direction, the value of G is positive. In the upward direction, we have to consider that as negative. So therefore, here acceleration due to gravity is the same as acceleration, and the car falls from a certain height. That means the car is falling in the downward direction. Therefore, the acceleration value is positive here. Okay, acceleration, comma a equals to 10 meter per second. Now first one, what is its speed on striking the ground? So what is the speed in striking the ground? That means we have to find out the final velocity. Okay, we know that v is equals to u plus 8. This is the formula, equations of motion. So we have three formula. One is v is equals to u plus 80, and here v value we have to find out. U value is known, that is 0, acceleration is 10, and the time is half second. So therefore I will substitute here. You have to comment with the answer v equals to 0 plus 10 into half. So therefore, what is the value of final velocity? Just do the calculation and comment with the answer. Okay, we have v equals to u plus 80. Final velocity we have to find out in the first sub question. And initial velocity is 0 because object is initially at rest. And acceleration is same as acceleration due to gravity. It is in the downward direction. That's why it is plus 10. And time is given as half second. Just solve this and comment with the answer. Fast. Comment with the answer fast. Five meter per second. Any other answers? Virappa, your SI note is wrong. Jeevan, Tejashwini, Deepa, Sangmesh, Prakash, Maltesh, give the answer as 5 meter per second. Okay, we'll check this. V equals to 0 means 0 plus anything is 0. 0 plus anything is that number. Okay, then 2 ones are 2 5. So answer is 5 meter per second. So one thing I have observed here is some are writing the unit as meter per second. Some are writing unit as ms raised to minus 1, and some are writing m bar s raised to minus 1. So this method is correct, this method is correct, this method is wrong. Okay, if bar is present, then no need to use raised to minus. If you use minus in the power, no need to use the bar. Okay, that is the wrong method of representing the SR unit. Only these are the two methods to represent velocity, that is meter per second and ms raised to minus 1. This is the first part of finding the final velocity. Now the second part is we have to find out what is its average speed during the 0.5 second. What is the average speed during the 0.5 second? And average speed, that is equals to initial velocity plus final velocity divided by 2. Okay, I will solve the next sub question. B, average speed that is equals to u plus v divided by u value 0, v value is 5 divided by. Now comment with the answer. What is the value of average velocity? What is the value of average velocity. Coming with the answer fast. Average speed means initial velocity, initial speed plus final speed divided by 2. So initial speed is 0, final speed is 5. Therefore it becomes 0 plus 5 divided by 2. 2.5 meter per second. Any other answers? All are giving the answer as 2.5 meter per second. Any other answers apart from this? Okay, your answer is correct. So 0 plus 5 is 5 by 2 and that is equals to 2.5 meter per second. 2.5 meter per second. That is the answer for the second sub question, that is average speed. The third one, we have to find out the how high is the ledge from the ground. That means we have to find out the height. So height in terms of we have to find out distance. Okay. So I will solve the third sub question now. So your distance comma s equals to ut plus half at square. Ut plus half at square. S equals u value 0, initial velocity, time is half plus half into acceleration is 10 meter and time is half. Also, just simplify this. Okay. Be careful while solving this. S equals to 0 into anything is 0 plus 2 ones are 2 5s. So it becomes 5 into 1 square is 1, 2 square is 4. So therefore answer is 1.25 meter. S equals to 1.25 meter. That is the height. Therefore height equals to 1.25 meter. How many of you got the correct answer? Comment your name. How many of you got the height as 1.25 meter? Just comment your name. Fast. Comment me fast. I have to solve the next problem now. The next one. Example 10.3. Example 10.3. An object is thrown vertically upward and rises to a height of 10 meter. Calculate, first one, the velocity with which the object was thrown upward and the time taken by the object to reach the highest point. So here, in this case, the object is moving in the upward direction. Object is thrown and that is going in the upward direction. So therefore, here we have to consider the acceleration as negative value. Okay, here they not give the acceleration due to gravity as 10 meter per second square. So in the previous problem they gave the value of small g as 10 meter per second square, but in this problem they not give the value of small g as 10 meter per second square. Okay, that's why we have to use 9.8 meter per square only. Okay, actual value of small g is 9.8 meter per second square, but in the previous problem for the easy solution, they ask us to take the value of g as 10 meter per second. But in this problem, they not mentioned the value of small g as 10 meter per second square. Therefore, we have to consider the exact value, that is 9.8 meter per second square. And it is given that it reaches vertically 10 meter height. We have to calculate the velocity with which the object is thrown upward. That means we have to find out the initial velocity. And second one, the time taken by the object to reach the highest point, and we have to find out the time taken. First I will write the given data. Distance traveled, that is s equals to 10 meter. The next one, the final, because the object reaches 10 meter. So at the end point, the final velocity is 0. Final velocity comma v equals to 0. The next point is we have to consider the acceleration due to gravity. Acceleration due to gravity. That is g equals to 9.8 meter per second square. G value is 9.8 meter per second square. Now we have to consider the acceleration of the object. Acceleration of the object, that is k. But now the object is moving in upward direction, that's why it is minus 9.8 meter per second. Minus 9.8 meter per second. So these are the given data. Based on these data, we have to find out the initial velocity and time. First one, v square, or we know that, I'll write. We know that v square equals to u square plus 2as. V square equals to u square plus 2as. V square value is 0 here because v is 0, that is equals to u square plus 2 into a value is 9.8, that is minus 9.8, and s value is 10. S value is 10. So therefore 0 equals to u square, plus into minus it becomes minus, 10 into 9.8 it becomes 98, and 98 into 2, okay, that is 98 into 2, that means 98 plus 98, 8 is a 16, 1, 10 plus 1, 196. 196. So therefore u square equals to minus 196 goes to the side, becomes plus 196. Now therefore u equals to square root of 196. Now comment me what is the value of square root of 196. You comment me the answer. So I will explain once again. Distance is 10 meter is given, and final velocity because the object finally reaches a particular height. So therefore in that case final velocity is 0. And acceleration due to gravity is 9.8 meter per second square. But here the object is moving in the upward direction. Therefore we have to consider the acceleration of the object as minus 9.8 meter per second square. Here the object is moving in the upward direction, that's why we have to consider negative. If the object is moving in the downward direction, then we have to consider positive. Then we know that v square is equals to u square plus 2as, and when we substitute it becomes u equals to square root of 196. So therefore what is the value of square root of 196? It is 14 meter per second square. Any other answers? Okay, square root of 196 means it is 14 meter per second. So this is the initial velocity of the object with which it is thrown in the upward direction. Now we have to find out the time taken to move the 10-meter distance. Again, we know that. Again, we have to use the equations of motion formula, that is V equals to U plus H. Here we know the value of V, that is 0. We know the value of U, that is 14. We know the value of A, that is minus 9.8, and we have to find out value of T. So V value is 0, that is equals to U value is 14 plus A value is minus 9.8 into T. So it becomes 14, when it comes to the other side, it becomes minus 14 equals to minus 9.8 into T. Therefore T equals to minus 14 divided by 9.8. Okay, I think you understood up to this. This is also minus, okay. And here both the numerator and denominator is having negative sign, that's why it gets cancelled, and it becomes 14 divided by 9.8. So if you find difficult in dividing this term, then you can put the negative decimal point to the next term. It becomes 98. So when it moves in the forward direction, in the similar manner, you have to move the decimal point in the numerator also 1 digit forward. So here no decimal point is present, that means it is present here. So when we move this, it becomes 140. Therefore it becomes 140 divided by 98, and this value is equals to 1.43 second. SI of time is second. Okay, 1.43 second. This is the solution of the second problem. Let's look at the steps. How many of you understood this? Just comment your name. The next problem. That is example 10.1. Example 10.1. The mass of the earth is 6 into 10 raised to 24 kg. The mass is given. And that of moon is 7.4 into 10 raised to 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer, calculate the force exerted by the earth on the moon. And given that G value is 6.7 into 10 raised to minus 11 Newton meter square per kg square. So here the mass of the earth is given, mass of the moon is given, and the distance between earth and moon is given, and value of gravitational constant that is given. Now you have to find out what is the force that binds the earth and the moon. That one we have to calculate. For that we have to consider F is equals to G into mm divided by d square. That formula we have to consider. So before going to solve that, first we will write the given data. First one is mass of the earth, and one more thing, so all the unit must be in S unit. Okay, because your distance is given in terms of kilometer. Okay, that is 3.84 into 10 raised to 5 kilometer. So we have to convert that kilometer value into meter value, then we have to solve that. The first one, mass of the earth. Mass of the earth. Consider that as capital letter M. that is 6 into 10 raised to 24 kg. 6 into 10 raised to 24 kg. And then mass of the moon. Mass of the moon, I will consider that as small at m, that is equals to 7.4 into 10 raised to 22 kg. 7.4 into 10 raised to 22 kg. And distance between Earth and Moon. Distance between Earth and Moon, that is equals to 3.84 into 10 raised to 5 kilometer. So that is equals to 3.84 into 10 raised to 5, and kilo means 10 raised to 3. It becomes 10 raised to 8 meter. Now we have to find out the force and acceleration value of capital G, gravitational constant. Gravitational constant, that is value of capital G, that is 6.7. They give directly. Okay, 6.7. Actual value is 6.672 into 10 raised to minus 11 Newton meter square per kg square. But here they give 6.7 into 10 raised to minus Newton meter square per kg square. And we know that F equals to G into mm divided by T. G into mm divided by T. Just I will substitute the value here. F equals to G value is 6.7 into 10 raised to minus 11. Then value of capital M. Capital M means mass of the earth. That is 6 into 10 raised to 24. Then M, small m means mass of the moon. That is 7.4 into 10 raised to 22. Divided by, so here d square. Okay, d square means d value is 3.84 into 10 raised to 8 whole square. 3.84 into 10 raised to 8 whole square. Okay, this is just look at the substitution. Just look at the substitution. Here value of G is 6.7 into 10 raised to minus 11. Value of M is 6 into 10 raised to 24. Value of small m is 7.4 into 10 raised to 22. And value of T is 3.84 into 10 raised to 8. Then T square is, it becomes whole square. So you have to square 3.84 as soon as you have to square 10 raised to 8. So it becomes 10 raised to 16. Here it becomes 3.84 into 3.84. Finally it comes as F equals to 2.01 into 10 raised to 20 Newton. 2.01 into 10 raised to 20 Newton. That is the force between the earth and the moon. That is the force between the earth and the moon. Thank you, Ron. I will continue in the next class.